let's start with linear data structures. Linear data structures, I am sure many of your teachers might have talked about it. Many of you might have understood, might have not understood it, but need not worry. It's not a very great concept, very important concept. We just need to know over our head what it is, and once you know what it is, there will be no use other than that. We just need to implement those linear data structures. So linear data structures are where the elements as in your data is arranged in sequential order that we have. So the in linear data structures, only one first element will exist, and there will be only one next element to it. So and only one last element will exist, and only one previous element exists. Now, for example, if I have to give you an analogy, consider now array is a linear data structure, and this will be the first element of the array. There will be no first other than this array element. There will be no other first array element. So that is what linear data structure is. There is one first element, there is one last element, and there are only just one connection between them. Like one element will have just one child. There will be no children, and children will exist in non-linear data structure for a particular element that will exist. So yeah, so examples of linear data structures are arrays, lists, stacks, queues, etc. So if at all there are any doubts by this point, I will motivate you to put those doubts in the chat section. While I'm presenting this, the other members will be happy to clear your doubts, and feel free to post your doubts on the chat section for right now. After this gets over, we'll be opening the platform for doubts for you to unmute and ask. So yeah, whatever will be the doubts, feel free to ask. Now let's come on to our first data structure, and that would be the first linear data structure, the most basic of them all. We'll be talking about array data structure. Now array is the most first and the basic data structure that you might have learned in your data structures practicals, and you might feel very easy, very eager to code in arrays. But let me tell you that array has its own limitations that we'll be talking about in the disadvantages section of arrays, and those disadvantages are solved later by dynamic arrays. We'll be talking about them too. So coming on to the features of array, the first feature, as I said, it is a linear data structure. Like by linear, I mean that every element will have just one next element, and every element will have just one previous element. There will be no children, and there will be no multiple elements that it will be associated with. Now, the next feature is it will have contiguous memory allocation. So by contiguous memory allocation, what I mean is that in your memory, in your RAM, or in your primary memory or in your secondary memory, the elements, the data that is present in your array will be stored at contiguous memory allocations, that is one after the other. So if I were to tell you that the first array element, that is the array element at index 0, is present at a memory location named 1000, then the next will be present at say 1004, the next will be present at 1008, and so on. Now that will depend upon your system, upon your compiler, as to how many bytes of data it is allocating to a particular data type. If you are using, if you are working with integer arrays, then the memory allocation gap will be different. If you are working with character arrays, it will be different. But what I meant by contiguous memory allocation is that the elements will be present one after the other, even in the memory. So what would that achieve is that random elements are easily accessible. Now, since arrays are present one after the other, and they are indexed, like if someone asks me what is present at the 7th position of the array, so what I will do is I'll just index it at array of 6, and I'll get the element, that is get the data that is present at the 7th position of the array. Now many of you might know that arrays are zero based indexing. So the 7th position of the array is achieved by the number 6, and so on. So random elements are easily accessible by their index, and they are homogeneous. Yeah. So like only one data type of array can be created at once. So if you're specifying an array of integer data type, all the elements present in the array should be of the type integer, if you are presenting an array of float data type, then all the elements should be of the float data type. You cannot mix up a character array in an integer array and expect your program to work. That will give you error and your code won't work. So that were the features of array data structure. Now moving on forward, we'll be talking about the advantages of array data structure. As I said, the access of elements is the primary importance of the array data structure. Whenever you want to achieve efficiency in your code, so if at all you are familiar with the concepts of time complexity, space complexity, you may understand that how important of a role they play in achieving efficiency in your code. So easily accessible elements, by that I mean that your code will be able to access a particular element in O of one time, that is big O of one time. So it will need a constant big O of one time to gain the access to that particular element. So that is what is the benefit of array data structure. Now the second advantage is that traversal is easy using loops. So as I said, since they are indexed, arrays are indexed, zero-based indexing or one-based indexing, it depends. So since they are indexed, you can easily traverse the entire array to perform a certain operation on them using the loops. So if at all, like you must be knowing that we initiate an integer variable I, and generally if it is taken as I, and we initiate it with the value of 0, and we run the loop for the size of the array, and we go from the first element to the last element checking for certain things that we need to achieve in the code. So this is what traversal means, and that is very easily done in an array. So yeah, and then the faster sorting and searching. Now sorting and searching techniques come under the algorithms part, and it will not be under the scope of this particular session to talk about the algorithms part. But don't worry, we'll soon be coming out with the algorithm session as well, and we'll be talking about the sorting and searching techniques as well. I'm sure you must know sorting techniques like bubble sort, shell sort, merge sort, and insertion sort, selection sort, etc. And searching techniques like binary search, etc. So these sorting and searching techniques, when applied on an array, you will be able to achieve whatever you want to achieve from your code. Now, for example, if you want to search for a element, for the maximum element in your array, and then you can achieve, and it is an unsorted array, then you can achieve that using the binary search technique. Now that would be great if it is an array data structure, and that is a particular advantage of array. Now fourth point of advantage is that it can be used to implement other data structures as well. So at the beginning of this session, as I said, stacks can be implemented using arrays. So yeah, so that is an advantage of arrays, like we can implement stack using arrays. So now coming on to the disadvantages of the linear data structure array, it is that it has fixed size. So by fixed size, I mean that whenever you want to work with arrays, you need to tell your compiler beforehand that what will be the size of this array, what will be the type of elements that will be existing in this array, and if, for example, you initiate an array, you declare an array using the size of 5, and while working in your code, if you want to give the sixth element in your array, then it won't be able to do that, because that particular array will have just 5 memory locations allocated to it to store the integer data type. The data type is not important, but what I'm trying to convey is that it has fixed size, and that is what the disadvantage is. In some of the codes, you won't know in the runtime how much elements that you want to give access to that array, or you want to store in that particular array. So this acts as a disadvantage. And the second disadvantage is that insertion and deletion is tough. By insertion and deletion is tough, what I mean is that if you want to, if say you have an array of size 10, and you want to insert an element at the 5th position, and then in order to insert an element at the 5th position, you will have to first take all the elements and store them in the next index. That is, you will have to shift all the elements by position 1, and then at the array index 4 you will have to store it. So that is what the disadvantage is, because it receives because it needs a lot of computation in the shifting part. It will not achieve efficiency in the time complexity part. So yeah, that is what is insertion problem. And deletion also same. If you want to say all the 10 elements are filled in this particular array, and you want to delete the element present at the first index. So what you will have to do is that you will have to take the element at index 1, store it in index 0. You will have to take the element at index 2, store it at 1, at 3 to 2, 4 to 3, and so on with the entire array. And you will have to traverse the entire array. So that will be taking again a time complexity of O of n, that is linear time complexity. And then after that you will have to delete it. So yeah, that is one particular disadvantage of arrays. And the last disadvantage that I can think of on the top of my mind is that if the capacity is greater than the size, then the memory is wasted. So if for example I have declared an array of size of capacity 100, that means that I have ordered my code to secure 100 memory locations in the memory for this particular array. But in the end, I'm just inserting 50 elements in my array. Then the other 50 elements which were reserved for this particular array, that would be the memory for them would be wasted. So yeah, that is the particular disadvantage of array. Now moving on forward, let me cover up the operations, basic operations that are associated with array fast. So yeah, the first is declaration. Now this is the variable name array. This variable can be named anything. I can name it A, B, C, or say ARR, anything. So that is how I have declared an array of the type integer, which will have the capacity of 10 integers to store, of an array of name array, which will have all the elements of the type integer, and it will store at max 10 elements. That is, the capacity is 10. So this is the array declaration by specifying the size. Now, the next way to declare an array is by taking user input. Now here we had predefined it in our code, but by taking user input also we can do it by first declaring an integer named n, and we'll be taking the user input via the cin and storing the user input of the size in the variable named n, and then we'll be declaring the array of that particular size. Now the next method is by declaring by initialization of elements. If you were to declare your array in this way, and then you need not specify the particular size here in the parenthesis, because the code will know that there are 5 elements associated with array ARR, and it will do the rest of the work by its own. The next way is to specify both the size and the array elements. So this particular thing is called declaration. These both things are called declaration and initialization. That is, we are declaring the array and we are initializing it with a particular value. So that is where the declaration operations associated with an array. Now the searching operation. So let's say you have an array of variable named ARR, where you have initialized it with values 2, 1, 4, 5, 7. And if you want to, for example, here we have not taken user input. Here we have just hard coded the value, but you can take this user input. You can ask the user which element you want to search in that particular array. So here, if we want to search the element 4, then how to search for it in arrays is that we declare a for loop, where we declare a for loop variable I and initialize it with the value 0. We run the loop for 5 times. So the values will go from 0, 1, 2, 3, 4. And at value I equals to 5, the loop will break. So what happens inside the loop is that at every value of I, it will index the array ARR, and it will check if the element at that particular index is the element that we are searching for. So in this case, it will start with the value 0. So array of 0 may value have 2. Array of 1 may value have 1. Array of 2 may value have 4. So when the value of the variable I will be 2, we'll get the element that we wanted, and the search will end. And then we'll return the value of I, that is the index of the location where the element was present. So this is how searching happens. And if at all we do not get the element, that is we do not return from the function, then it will come out of the loop and present to the user the message that element was not found. Because if the element would have been found, then it would have, then the code would have returned from this position only. This part of the code would have not executed at all. So that is how searching happens in the arrays. Now deletion. So yeah. So what happens is we have declared an array by the variable name ARR, the same array 21457. Now this is the element to delete. Now to delete a particular array, we need to understand where that array element resides in that particular array. So what we do is we pass the array, the number to be deleted, and the size of the array to a function named search. This search function will return the index. As I said, this was the search function we were talking about. It will return me the index of the element present, that is the num element. So we'll get the index stored in the variable named idx, and then we'll start our loop from I equals to idx until the end of the array, and then we'll just copy the next element into the current element. So we are effectively deleting the existence of that element by copying the next element into the current element, and this happens until the end of the loop. So we have achieved what we wanted to achieve, that is deletion. Now the next is the insertion in an array. So say that the same array is present and the element to be inserted is 4, and we want to insert it at the position indexed 2. So 2 is the position at which the element is to be inserted. So on the zero based indexing of array, we'll have 0, 1 and 2. So this is the position where we want to insert the array. So we'll start from the end of the array at location 5, and then we'll move on for backwards by doing I minus minus, and then we'll be copying into array of ith position the element present at array of I minus 1 position. So effectively what we are doing is we are helping us to create a vacant position at the array index 2, and then at array index 2 we'll insert the element 4. So we have achieved what we wanted to achieve, that is insertion. Don't worry if you have not understood this part of the code. We'll be sharing the codes as well with you. I'll be talking about them at the end of this session. So yeah, that were all the basic operations that were present in an array, right from declaration, searching, deletion, and insertion. Now coming to the applications of arrays. So the real world application of arrays is that it helps us in representation for multiplication and division operations. There is matrix multiplication is achieved using multidimensional arrays and so on. So it helps us doing that, and it also helps us to store a 2D image as a bitmap. So in your phone, the image rotation, things like image processing, I've talked about it in the industrial application. So what happens is that in your phone, the image that you see is stored in the form of a two-dimensional array. The first pixel of the image is stored at the location 0, 0. The second pixel is stored at 0, 1, and so on until the last pixel. So this is what is achieved using a multi-dimensional array. That is, you can store an image, and if you were to crop that image, if you were to rotate that image via 90 degrees, then all you have to do is just change the index of the element and then we achieve it. So that is what one particular implementation of array. Then the third implementation is that we can implement the other data structures using array, as I said. And in database records, like database records are if we want to extract a particular row of a particular database of a particular table, then we can store them in arrays. Of course, not an integer primitive array. There exists arrays where we can store multiple data types, and that we can use for database records. And then in CPU scheduling algorithms, also we use arrays. So if you are in your second year, do not worry about this CPU scheduling algorithms. You will be learning about them in a subject called operating system. If at all you belong to the IT comms department, you will be learning about CPU scheduling algorithms in your third year or your fourth year. and then you will understand how arrays are implemented there. It's a bit complex to talk about them in this session. That is why we are not going to the depths of it. So yeah, that was what arrays are all about. Now, as I can say, the major disadvantages of working with array is the fact that they are of fixed size. We have no methods to change the size of a already declared array if at all we need to change its size during runtime. If at all our code finds out that there are more elements that it needs to work with than the ones which were initialized with at the beginning, then there is no mechanism for you to change the memory space that was allocated to a particular array. And to solve this particular downfall of array data structure come into picture the vectors data structure.